Hello everyone, welcome to our first part of our semester 1 review for pre-calculus. So today we are going to go through numbers 1 through 14. So let's dive right into it. The first couple talk about average rate of change. In case you've forgotten, average rate of change is pretty easy. It's just slope. It's just a slope formula. It's like taking y2 minus y1 and dividing it by x2 minus x1. That's all it is. Sometimes they don't give us y2 minus y1. Sometimes they have to plug stuff in to figure out what the y's are. It just depends. In this case, everything they gave us, they already told us the y's, which makes it kind of easy. So for this first one, the information tells us that there is a halftime show happening. Every 5 minutes, they took a poll at how many likes had happened in the last 5 minutes in number of millions, and we can see what happens. So it says, what's the average rate of change from the beginning of the halftime show to the end of the halftime show, including units? So we're going to start with our change in our y values, which is going to be the change in likes. So at the end of the halftime show, they were collecting 88 million likes in 5 minutes, where at the beginning it was only 26 million. So we're going to start by going 88 minus 26 million. And then on the bottom, we're going to subtract our time, our x. So I did 88 minus 26. So on the on the bottom of our fraction, we're going to do 1040 minus 1015. 1040 minus 1015. Now that is kind of weird because we're in time, right? The top part's pretty easy. We just subtract 88 minus 26. That's going to give us 62. That's easy. The bottom part gets a little bit weird though, but we would just do a little bit of math like we were doing on a clock. From 1015 to 1040, 25 minutes have passed. So that looks like in 25 minutes, there's an average of 62 million likes every 5 minutes. So if you divide that, you're going to get 2.48 million likes per minute. 62 divided by 25 gives us that 2.48, and that is our units. It says, if possible, approximate the intervals in which the number of likes is strictly increasing. So if I'm looking at my table, I can see that at the beginning it goes from 26 to 48, so that's an increase. And then from here it goes to 37. So it looks like from 1020 to 1025, it actually decreased. So it looks like we have an increasing interval from 1015 until 1020. That's our first increasing interval. But from 1020 to 1025, it goes from 48 million to 37 million, so it went down. But then it starts going up again, 37 million to 54 million, 54 million to 96 million, 96 million to 88 million. It went down again. So it looks like it's increasing from here to here. So from 1025 until 1035, we're increasing. Now remember, if we have two intervals and we want to put both of them, we use a union sign. So we unite those two increasing, and those are two increasing intervals. Question 2 kind of focuses on the same thing. This talks about Roger, who buys a toy airplane, helicopter thing. He flies a helicopter up over a 5 minute period of time. It goes up, it comes down a little bit, goes way high up, and then it crashes down to the ground. And they asked us to find some average rate of changes here. So it says find the average rate of change from point B to point D. So we're going to look at point B and point D and just do our change in y over change in x. So y2 minus y1 is going to be 60 minus 38. And then x2 minus x1 is 4 minus 1. Notice that I made sure that the first two numbers, the 60 and the 4, come from the same point. And the 38 and the 1, the second numbers, come from the second point. So you want to make sure that you have them in that same order, that you're not dropping the order on it. So I end up with 22 over 3. And when I do 22 divided by 3, I get 7.33 feet per, was it minute? Yeah, feet per minute. With D to F, D is at 460 and F is at 50. So again, we got x1, x2, and y1, y2. So y2 is 0, y1 is 60, so I've got 0 minus 60. And then x2 is 5, x1 is 4, so I've got 5 minus 4. 0 minus 60 is negative 60, 5 minus 4 is 1, so that's going to be negative 60 feet per minute. So that means that the helicopter is going down at that point. And last, I got C to E. Point C is at 233, point E is at 4.8533. So that's going to be easy. Look at our y value. y2 minus y1 is 33 minus 33. The bottom's going to have 4.85 minus 2, which gives me 2.85, but I really don't care because I get 0 on the top. And 0 divided by any number other than 0 is 0. So it's going at a rate of 0 feet per minute. And you can see that that's because this is right in the same line. The helicopter didn't change heights if you only focus on those 2 points. We know that it did go up and come back down, but between C and E, technically it never changed height. All right, number 3 says to evaluate the difference quotient. These ones are a little bit long, so I'm actually going to do this on a separate sheet of paper. But it gives me the equation f of x is equal to 5x squared plus 2x. And they asked me to calculate the difference quotient. So remember, the difference quotient is when we take that formula f and we plug in x plus h, and then we subtract f of x from it and divide by h. And whatever we get is going to be our difference quotient, which helps us to find the derivative, which is something you will do next year in calculus. So what we're going to do is we're going to start by plugging x plus h into our formula. So I have 5 times x plus h squared plus 2 times x plus h. So remember that this is this piece right here. Then I do minus f of x. So now I'm going to take this equation again, but I'm going to subtract it. So I'm going to do minus 5x squared and then minus 2x. So both of them get minus signs attached to them. All of that is divided by h. So now it's just a matter of going through and simplifying this. X plus h, remember that is the same thing as x plus h times x plus h. So if you just wrote x squared plus h squared, you would be wrong because that's not what's happening. It's x times x, which is x squared, x times h, and then h times x. So both of those give us xh, so there's 2xh, and then h times h, which is h squared, plus our 2x plus h minus 5x squared minus 2x. Again, all of that is going to be divided by h on the bottom. So now I can go through and distribute. I've got 5x squared. 5 times 2x is going to be plus 10xh. 5 times h squared is plus 5h squared. 2 times x is 2x. 2 times h is 2h. And then minus 5x squared minus 2x. You can see what's going to happen is some canceling here. This will cancel with that. And then the plus 2x will cancel with the minus 2x. What should happen is at the end, you should cancel anything from the minus f of x out. If you did it correct, you should always have those cancel out. And all of that is divided by h. So my final answer, I've got 10xh plus 5h squared plus 2h all divided by h. So we just take an h out of everything. 10xh, cancel out the h's, I get 10x. 5h squared, I cancel out one of the h's on top, so I have 5h. And then 2h, I cancel out the h, and I have plus 2. So my final answer is 10x plus 2 plus 5h. I'm going to rewrite it with the constant at the end. So let me put that here. 10x plus 2 plus 5h. All right, for number 4, A, B, and C, they have us plugging some stuff into these equations. Number 4 says, part A says h of x is the absolute value of x minus 2. Plug in 8. Well, all we're going to do then is plug 8 in here. 8 minus 2 is 6, and the absolute value of 6 is 6. Remember, the absolute value is how far is it away from 0. For this one, we're going to plug in negative 3x minus 12 in for x. So I'm going to have the absolute value of negative 3x minus 12. Then I got this little minus 2 at the end. Well, all I can do here is combine these like terms. Negative 3x minus 14. And I know some people do kind of have that force of habit. They want to just drop the negatives because we know it's supposed to be positive. That's not quite what we're going to do. We have to still leave it here, and just we'll come back to those minuses later. We're just going to leave it as the equation, the absolute value of negative 3x minus 14. We know that whatever our answer is, it's going to be positive, but we could just leave it like that. For part B, the first part says plug 3 into the equation 2x squared minus 1. So 3 squared is 9, and 9 times 2 is 18. 18 minus 1 is 17. For this one, we're going to plug an equation in. So this one we have to write out a little bit so we can make sure we get it right. We're going to plug in x plus 1. So I have 2 times x plus 1 squared. And then we have our minus 1. Again, this is just like that difference quotient. If you rush in too quick and you just go x squared plus 1, you'd be wrong. You want to make sure you actually FOIL that out all the way. So x times x is x squared. X times 1 and 1 times x is going to be plus 2x. And then 1 times 1 is plus 1. Then we got our minus 1 out here. And we can distribute that 2 in. 2x squared plus 4x plus 2 minus 1, which means our final answer is 2x squared plus 4x. 2 minus 1 will cancel, the 1 will go away and we'll get plus 1. That would be our final answer for that. For part C, f of x has a piecewise function that we have to work with this time. So now I've got to look at this piecewise function and figure out where these fit into this piecewise function. So this one says figure out what f of negative 2 is. So first we're going to look at that negative 2. And we're going to say, well, where does the negative 2, which inequality does negative 2 fit in? Is negative 2 less than 0 or is negative 2 greater than or equal to 0? Well, I know the value negative 2 is less than 0. So I'm going to use the top equation. I'm going to plug negative 2 into the top equation then. So 3 times negative 2 minus 4. So we're only plugging into the top equation values that are less than 0. So 3 times negative 2 is negative 6. Negative 6 minus 4 is negative 10. That is going to be my answer. B, I want to plug 0 in. Well, is 0 less than 0 or is 0 greater than or equal to 0? I know 0 is equal to 0, so it's going to be the second equation. So 3 times 0 plus 1. 3 times 0 is 0. 0 plus 1 is 1. And lastly, is 2 less than 0 or is 2 greater than or equal to 0? Well, 2 is greater than or equal to 0. So I'm going to plug 2 into the second equation. So 3 times 2 plus 1. I get 6 plus 1, which is 7. So again, you're just checking these numbers and figuring out which inequality they fit in and then plugging into the equation that it goes with. Number 5, this one is an interesting one. It asks us to figure out what the volume of a box is if we fold up the corners of a square sheet. So the first one says, use the table to estimate the maximum volume. Well, if I look at the volumes here, I got 484, 800, 972, 1024, 980, 864. So it looks like it goes up and it goes back down. So it looks like the highest value is 1024 centimeters cubed. So the maximum value is that 1024. The question says, what is the volume in terms of an equation? And then could we determine a domain for it? And we can do that. Think about this box here. If I start by doing 1 inch on each square, so if I fold each side up by 1 inch, meaning I make a box where the height is 1 inch. Well, let's think about what this inside base is going to be then. If I take away 1 inch on this side and 1 inch on this side, I'm taking away 2 inches. So when I plug in 1, I have to subtract 2 from the total of 24. So this becomes a 22 by 22 base because the 23rd and 24th inch become the height. So it would be 22 times 22 times a height of 1. And if you did that, you'd get 484. If I were to change these each to 2's and make each height 2, well, now when I fold it up, I fold up 2 on the left and 2 on the right, which means of the 24, I'm losing 4 centimeters. So now I've got 20 by 20 for the base, so that's 400, times the height of 2, which is 800, and that's where that comes from. So you can see what's happening. When I fold the box up, I take whatever the height is from the left and the right side. So I'm subtracting the height twice from the total. So what's happening is I'm taking the 24 total, and I'm subtracting the height, but I'm subtracting the height twice for each side. 1 and 1. Subtract 2, subtract 2. Subtract 3, subtract 3. Subtract 4, subtract 4. And that's going to give me the length of the box. Well, the width of the box is going to be the same because it's a square. So the length times the width is going to be the same number. So I'm squaring this value. Take 24 and subtract 2x from it and then square it. That's length times width. Then we times it by height. Well, I know height is x. So I'm going to times it by x again. And that is going to determine the volume of these cubes. Now it does say find the domain as well. Well, what I know is that the only way I can make this work is I have to fold the box up with some sort of actual height. So it can't be 0, but it can be anything greater than 0, right? I can fold the box up and have 0.000001 be the height. And I can fold it all the way up to a specific number. And that number, since I'm trying to keep it even on both sides, I can fold it up to 12 and 12. Now, if I fold 12 and 12, it's gonna fold in half. So I can't actually fold 12, but I could fold 11.99 on both sides. So it's gonna fold up to 12, but not reach 12. So the domain is 0 to 12, with 0 and 12 having parentheses around them because we're not actually folding on those marks. Because 0 would not make a box and 12 would just fold the paper in half. Number 6 says find all the real zeros. So with this one, the first thing that I noticed is that I could easily factor out an x, right? They all have x's in them. So I could factor an x out. I get 4x squared minus 16x plus 2.5. So now I could try to factor this. If I tried to find two numbers though that multiply to make 2.5 and add it up to negative 16, we multiply by 4, that gives us 10. So two numbers that multiply to make 10 and add up to negative 16, well that doesn't exist. Which means the only way I could actually finish getting my zeros is I'm gonna have to do the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So what that's gonna look like for us is 16 plus or minus the square root of 16 squared, which is 256, minus 4 times a, which is negative 16, times c, which is negative, hold on, 8, 9, 10. Oh, I'm messing myself up. 2.5 times 4 is 8, 9, 10. 10 times 4 is 40, so this is gonna be minus 40. All over 2 times a, so 2 times 4, which is 8. This will become 16 plus or minus 16, all over 8. And I'm just gonna pop that in my calculator. So 16 plus the square root of 216 divided by 8, and I get 3.83, so x equals 3.83. Then we'll do minus 16 minus the square root of 216 divided by 8, and I get 0.162, so 0.16. And there's one more 0. Don't leave out this little x that we factored out. In order to make that a 0, we just plug in 0, so it's also 0. So those are my three zeros, 3.83, 0.16, and 0. All right, turning this page on to the next side. Number 7 says classify the functions as even, odd, or neither. So in order to do this, we have two ways. You could start getting really good at even, odd, or neither, but if you don't really remember it, the way that we did this is we replaced the x with negative x. When you plug negative x in, if the function comes out the exact opposite, then it's odd. If the function comes out the exact same as it started, then it's even. And if the function changes and it doesn't look the same or it's not the opposite, then it's neither. So I'm gonna plug in negative x for x here. So I get negative x to the third power plus 1. Well, negative x times negative x times negative x is gonna stay negative, right? The negatives are gonna multiply. 3 negatives make a negative. So I get negative x cubed, and the plus 1 stays plus 1. Is that the exact opposite? Well, no, because the plus 1's still a plus 1. Is it the exact same? No, because the negative x cubed was a positive x cubed. So because it didn't change the exact opposite or stay the same, it would be neither. Right here, I've got negative x squared minus 3. Well, negative x to the positive even power is going to become positive. So this becomes positive x squared again. Negative times a negative twice cancels out the negative. The minus 3 stays. Well, look at that. That equation is the exact same as it started, so it is even. Part C, negative x to the 5th power plus negative x. Well, negative to the 5th power, negative to an odd power stays negative. So this is negative x to the 5th. And then plus minus x. Well, that's the same as just minus x. That's the exact opposite. So because all the signs changed, it is odd. Again, as you get through this, you're going to notice there are things you could pick up on. If all the exponents are even and there's constants, it's even. If all the exponents are odd and there's no constants, it's odd. And if there's a mix, then it's going to be neither. So right here, if we look, well, it doesn't matter what I plug in here. This one's kind of a weird one, but it doesn't matter what I plug in. Negative x is also x, and x is also x because it's absolute value. It's always going to stay the same, even if I switch it to negative. So that's going to be even. In part E, I've got an even power and an odd power. So since there's one even and one odd, this one's not going to change signs, but this one will. So this would be neither. And in the bottom, I've got an even power. So when I plug in negative x, it's going to go back to a positive. So since it's an even power, this will be even as well. All right, part 8 says identify which equation, piecewise equation, represents the graph. So I can see in this graph, it looks like I got this little kind of check mark thing coming down, and then it changes. So it looks like the graph is changing right here at 1. This side looks like an absolute value, and this maybe is like a parabola or a cubic function, something with a rounded shape. So I need an absolute value and then some sort of parabolic type shape. So absolute value when it's less than 1. A has an absolute value less than 1. B has a absolute value less than 0, but definitely between 0 and 1, it's still absolute value. So this is less than 0, so that's not it. C also is less than 0, so that's not it. D has less than 1, right? At 1 left, less than 1 is absolute value. So it's either A or D. What I notice then is when it's greater than 1, this one's a parabola because it's got something squared. And this one's a parabola because it's got something squared. In fact, those look really similar, except this has a +1 at the end, and this does not. So let's just try plugging something in. If I plug in 2, I should get 0. So 2 minus 1 is 1. 1 squared is 1. -1, when I attach the negative to it, -1 plus 1 is 0. So that does work. Let's try it down here. If I plug in 2 down here, 2 minus 1 is 1. 1 squared is 1. -1. And it should have been 0. So D does not give us 0 when I plug 2 into this equation. So it's definitely going to be A because when I plug in 2 for x here, I get 0 as a solution. Sorry, it wasn't even on the page. It was a little bit below it. But next says find the domain of each of the following functions. These ones are not super hard because there are no square roots. It's just fractions. Remember, the only thing that matters in a fraction is that the denominator cannot be 0. So what would make x plus 3 0? Well, x would be -3, and that would give me a 0. So I know that x cannot equal -3. And what would make x minus 5 equal 0? Well, if x was +5, it would equal 0. So x can't be +5. So let's put that in our interval notation. -∞ to -3, union -3 to 5, union 5 to infinity. What we're saying then is anything in between -∞ and -3, that works. We're going to skip -3 because it doesn't work. But anything between -3 and 5 works. We're going to skip 5, though, because that doesn't work. And anything between 5 and positive infinity does work. B is going to be very similar. What would make x plus 2 equal 0? Well, that would be -2. X cannot equal -2 because -2 plus 2 is 0. What would be 3 minus x equals 0? Well, this one's a little bit weirder to solve, but we could add x to the other side and we'd get x equals 3. So x cannot equal 3 because 3 minus 3 would give me 0. So those are my two values we can't be. So again, let's make our interval notation. -∞ to -2 works. Skip -2. -2 to +3 works, but we're going to skip +3. And +3 and everything to infinity works. So we're going to put in 3 to infinity. Part C, we have to finish ourselves. They didn't actually factor it for us, so we're going to have to do that. So we need to take that x squared plus 4x plus 4 and factor it. What two numbers multiply to make 4 and add up to make 4? Well, that's pretty easy. 2. X plus 2 and x plus 2. Well, it looks like then the only thing that x can't be, the only thing that would make this denominator equal 0 is that x can't equal -2. So I'm going to put -∞ to -2, skip -2, and go to infinity. And beyond. Woo! All right, coming up here to number 10. Number 10 says the annual cost in thousands of dollars for and the revenue are given by a company by these formulas. What would be profit? Well, if you don't remember what profit means and what revenue means and cost means, cost is how much we have to spend on something. Revenue is how much we're making from that. Profit is what we gain after we calculate what we had to spend. So I know that I'll find my profit by taking the cost of the revenue we get from the event and subtracting the cost of the event. So let's say we throw a prom, right? And prom costs us $1,000 to have, but we make $3,000. That doesn't mean we made $3,000 because we still have to take our $3,000 and subtract the $1,000 that we had to pay for it. It means we only made $2,000 in profit because the $1,000 had to go to pay for the expenses of our prom. That's how profit works. Take what we made, subtract what it cost, and that's our profit. So my revenue was 341 plus 3.2t. We're going to subtract our cost, which was 254 minus 9t plus 1.1t squared. And we're going to subtract here. So 341 minus 254. 341 minus 254 gives me 87. 3.2 minus 9 gives me negative 5.8t. And then 0 minus 1.1t squared is going to be minus 1.1t squared. So that is how we'd represent our profit. You may want to rewrite that as negative 1.1t squared minus 5.8t plus 87, and that's okay. If you want to write it in that order, that's okay too. 11 has a lot of stuff that might make it seem confusing. It's talking about bacteria in a refrigerator on food. But if you read through all that and you're confused, once you get here, it just says, well, interpret. What does n of t equal? That's all they're asking us to do. Plug little t into the t for time equation, get that solution and plug it into our number of bacteria equation. Well, I already plugged t into this equation. T of t is already 3t plus 2. What I now need to do is plug this equation into the n of t equation. So what we're going to do is we're going to take 10 t squared, but where the capital T is, we're going to plug this in instead, 3t plus 2, minus 20 times capital T. So again, for capital T, we're going to plug in 3t plus 2, and then plus 600. And we'll just work this out. 10 times 3t is 30t. 10 times 2 is plus 20. Negative 20 times 3t is minus 60t. Negative 20 times 2 is negative 40. And we have plus 600. So combine our like terms. 30 and negative 60 is negative 30t. 20 and negative 40 is negative 20. Negative 20 and 600 is 580. Oh, hold on. What am I doing? This had a squared on it. Jeez. Okay, hold on. Let me flip over to my paper because we're going to run out of room if I just do it on there. Sorry. Okay, so this was 10, and then I had 3t plus 2 squared. So that's going to give us 3t times 3t is 9t squared. 3t times 2 is 6t, and 2 times 3t is another 6t, so that's 12t. And 2 times 2 is plus 4. Then I have my minus 20 times 3t plus 2, plus my 600. Now I can distribute. Let's try that again. So 90t squared plus 120t plus 40 minus 60t minus 40 and then plus 600. So I can see that my plus 40 and minus 40 will cancel. And I have 90t squared. 120 minus 60 is 60, so I have 60t plus 600. And that would be my equation. It does also ask me to interpret what my data would be. We're talking about t in time, so I know that t has to be between 0 and 6 because that's what my original function had. So I need to put the 0 to 6 in for my domain. Okay, coming up to this next set, A through F talks about taking this equation f of x and working through it to figure out what all my parts are in this rational equation. So the first thing I probably want to do is I actually want to probably factor this rational equation. So let me do that right here just so I have enough space. What two numbers multiply to make negative 2 and add up to negative 1? Well, that's going to be x minus 2 and x plus 1. Negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. My denominator is the difference of two squares, so I've got x minus 1 and x plus 1. So with that, I can see these two are going to cancel, and I can see what my rational function simplifies to. So this part says, does it contain the point 3, 2? Well, let's try plugging that point in. If I plug in 3 for x, I should get 2 as a solution. So 3 times, well, we can just plug into this one. This is the easiest one. Plug 3 in here. 3 minus 2 is 1. Plug 3 in here. 3 minus 1 is 2. So when I plug in 3, I get 1/2. Is that equal to 2? It does not equal 2. So this would be no. That point is not in the function. The function contains the point 3, 1/2, not 3, 2. Find the vertical asymptote. Remember, the vertical asymptote comes from the denominator. What would make x minus 1 equal 0? Well, it would be when x equals positive 1. So my vertical asymptote is that x equals 1. Identify the removable discontinuity or the holes. Remember, that's where we canceled. So I canceled out x plus 1. That tells me that x can't be equal to negative 1. In order to finish figuring out what the removable discontinuity is, though, we need to plug negative 1 into this problem. Negative 1 minus 2 is negative 3. Negative 1 minus 1 is negative 2. I can see that here those are going to cancel. I get negative 1. The two negatives cancel, and I get positive 3/2. So negative 1 3/2 is the removable discontinuity hole. Identify the horizontal asymptotes. Those are the rules. Remember, if the numerator is bigger, then there is no horizontal asymptote. If the numerator is smaller in power than the denominator, then the horizontal asymptote is 0. And if they have the same power, then we divide the leading coefficients. Well, if I look here, I've got a power of 2 and a power of 2. So since they're the same, we just divide the leading coefficients. In this case, 1 and 1. So my horizontal asymptote is y equals 1 divided by 1, which is just y equals 1. Identify any and all zeros. The zeros come from the numerator. Whatever would make the numerator equal 0. In order to make this equal 0, I'd have to plug in 2, because 2 minus 2 is 0. So my zeros are 2. And identify the y-intercept. The y-intercept comes from the constants. If I plug 0 in, I'd be left with negative 2 on top. If I plug 0 on the bottom, I'd be left with negative 1 on the bottom. And negative 2 divided by negative 1 is positive 2. So my y-intercept, when I plug in 0, I get positive 2. All right, let's flip this paper over. Going on to number 13. We're almost done with day 1. 13 says, find the slant asymptote. Well, what I notice is that when I try to factor this, it doesn't factor very nicely. It does factor a little bit. There is a removable discontinuity that you could cancel out from there, which is the x minus 2, if you wanted to do it that way. But then you have to know what the difference of two cubes is. If you don't remember that, then you wouldn't be able to do that. If you do remember the difference of two cubes, though, you might say x minus 2, x squared plus 2x plus 4. And then on the bottom, when I factor this, I'm going to need a negative 3 and a negative 2. So x minus 2, x minus 3, and then cancel, cancel. And then you could use synthetic division. That would work. So if you understand that, you could definitely do that. If you don't remember your difference of two cubes, though, or your sum of two cubes, which are easy to forget, you could just use long division, and that's what I use to do this. It says take x cubed minus 8 and divide it by x squared minus 5x plus 6. So that's my divisor. X squared minus 5x plus 6 goes on the outside of the long division. My dividend is the x cubed minus 8. X cubed minus 8. I left a big space, though, because we're missing some terms. We're missing the x squared, so I'll put plus 0x squared. And we're missing the linear term x, so we'll put 0x. Now I can go through and do this. What do I have to multiply x squared by to get to x cubed? I have to multiply it by a single x. Then we multiply, change our signs to subtract. X times x squared is x cubed. Change the sign, it's negative x cubed. X times negative 5x is negative 5x squared. Change the sign, it's positive 5x squared. X times 6 is positive 6x. Change the sign, it's minus 6x. Now I can go through. This cancels. 0x squared plus 5x squared is 5x squared. 0x minus 6x is minus 6x. And bring that down to hold our place. x squared times what is 5x squared? That's a plus 5, so I'm going to put plus 5 here. 5 times x squared is negative 5x squared. When we change our signs, 5 times negative 5x is negative 25. Change the sign, it's positive 25x. And 5 times 6 is 30. Change the sign, it's minus 30. Here's the deal. We don't really care about this actually, though, because when I do this, I'm going to get 19x and negative 38. Well, there is nothing that we can multiply x squared by to get to 19x. We just can't because it's too big. So we remember this is the remainder. I don't care about that. Slant asymptote just is this. The slant asymptote is y equals x plus 5. I don't really need the remainder. It's not very useful here. And last is solve the inequality. 6 over x plus 3 is greater than or equal to 1. With inequalities, we don't want them to equal anything other than 0. 0 is what we can work with. So I need to solve this into an equation that is equal to 0. So 6 over x plus 3. And what I'm going to do is I'm going to subtract 1 from both sides. So this becomes minus 1 is greater than or equal to, and that cancels out to 0. That is the same exact equation, but now I can actually solve it. I can combine these into one single fraction. To do that, I'm going to need a common denominator. So 6 over x plus 3 minus, well, the only way to get this to have a common denominator is to put the x plus 3 down here, which means the numerator has to be x plus 3, because x plus 3 divided by x plus 3 is 1. So when I combine this 6 minus x plus 3, I know that my denominator stays x plus 3. I get minus x, and 6 minus 3 is plus 3. Is greater than or equal to 0. Once I'm here, I think about my critical points. What would make my numerator equal 0? Well, the only way to get the numerator equal 0 would be to plug in a positive 3. So I'm going to make a little number line, and at positive 3, I have a critical point. The only way to make my numerator equal 0, or sorry, my denominator equal 0 would be to plug in a negative 3, because negative 3 plus 3 is 0. So negative 3 is also a critical point. So what I can do now is plug these things in and see which one would work for this equation, or the original equation. That's a little bit easier to plug into. So negative 4. Negative 4 plus 3 is negative 1. 6 divided by negative 1 is negative 6. Is negative 6 greater than positive 1? No. So the values less than negative 3 don't work. Pick a value in between negative 3 and 3, which is 0. That's a good one. 0 is right in the middle. 6 over 0 plus 3 is 6 over 3. 6 divided by 3 is 2. Is 2 greater than 1? Yes. 2 is greater than 1, so the middle works. And plug something bigger than 3. Let's say 4. 4 plus 3 is 7. 6 divided by 7, well, that's a fraction, and that fraction is less than 1. So is 6 over 7 less than 1 or greater than 1? It's not greater than 1, it's less than 1. So this doesn't work. So I know only the values in between negative 3 and 3 work. Then I have to think about whether negative 3 or 3 themselves work. If I plug negative 3 in, negative 3 gives me a 0 in the denominator. Is that allowed? No. So I need to put a parenthesis because I can't have a 0 in the denominator. If I plug in positive 3, that gives me a 6 in the denominator. That is allowed. But it gives me a 0 in the numerator, which would be 0 over 6, which is 0. Is 0 greater than or equal to 0? Well, yes, it's equal to 0. So here I've got to put a bracket because it's equal to 0 and that's allowed. So my solution is the values between negative 3 and positive 3, including positive 3. Hopefully that helps you out and you've gotten yourself through this now. Let me know if you have any questions. Thank you so much. Bye.